Settle in and let your breathing slow, like a tide that has nowhere urgent to be. The air around you is warm and wet, heavy enough to feel like a blanket. You might think you are looking at simple jungle, just green, just leaves. But the ground is a quiet argument, all mud and roots and water, always shifting under your feet. Tonight, you will drift with me, the sleepless geographer, along the edge of the map, through the Darien Gap, and onward to rivers, mountains, deserts, ice, fire, and the patient cliffs carved by time. Nothing here is in a hurry, not even the earth. You are standing in the Darien Gap, which sounds like a single tear in a map. It is not a single thing. It is a whole mood, a messy blend of river corridors, swampy flats, low ridges, and forest so thick it feels stitched together. The line between land and water is negotiable, and the sky, even when you cannot see it, still feels close enough to touch. You think the jungle is a wall of plants, just green, just chaotic. But the real obstacle is lower down, where your boots meet the ground, and the ground refuses to agree. Mud here is not a surface. It is soil, half dissolved, mixed with leaf rot and warm rain, and it behaves like it has its own plans for your ankles. The Darien lives between Panama and Colombia, where the idea of a smooth road quietly gives up. The Pan American Highway, that long thread of pavement meant to stitch two continents together, stops here like it has seen something it does not want to discuss. People will give you political reasons and engineering reasons and environmental reasons, all true. But the oldest reason is simpler. This landscape does not invite straight lines. Take a step, and the ground answers with a soft, wet sound. The roots under you are not decorative. They are survival equipment for the trees, gripping soil that wants to slide. Every trunk is anchored in a world that keeps trying to liquefy. If you want a calm fact, here is one tropical rain can fall so often that the earth never gets a chance to fully dry. The jungle runs on constant moisture and constant decomposition, recycling everything, including your confidence. Even the air has weight. Humidity presses against your skin, and the sweat does not evaporate like it does in polite climates. It just stays. The forest keeps it like a collector. And because the air is full of water, sound behaves strangely. Insects buzz close like they are inside your thoughts. A bird calls, and the call seems to come from everywhere and nowhere. Somewhere, water moves over stones, but you cannot tell if it is 10 steps away or 10 minutes away. You learn quickly that distance is a liar in dense forest. A ridge that looks near is still hours away, 'cause you cannot walk in a straight line. The jungle is full of small negotiations around a fallen tree, over a slick root, through a patch of undergrowth that does not want you. Progress is measured in patience, not miles. Congratulations, you have discovered the slowest possible way to move across Earth without technically standing still. And the Darien is not just thick forest. It is also wetland and floodplain and places where the ground turns to shallow water without warning. In a swampy stretch, you are not sure if you are stepping onto soil or onto a floating mat of roots and plants. It holds you until It does not. The difference between stable ground and a hidden pool is sometimes a single leaf. This is one reason the Darien Gap has a reputation that sounds almost mythical, not because it is cursed or because it is supernatural. It is because it takes ordinary physics, water, gravity, heat, and plant growth, and stacks them in a way that makes human schedules feel silly. The jungle is alive in a practical way. Plants compete for light, and they do it ruthlessly, climbing, choking, leaning, and reaching. Leaves overlap like shingles. Vines tie trunks together like cables. Down low, fungus and insects work through whatever falls. Nothing is wasted. The forest does not mourn. It processes. And you, in the middle of it, are not the main character. You are a warm animal walking through a system that has been refining itself for a very long time. The Darien sits in the tropics, close enough to the equator that day length does not swing wildly through the year. The sun rises, the air warms, moisture lifts, clouds build, and rain arrives again and again. Like a habit the sky cannot break. If you listen carefully, you notice another truth. The forest is loud, but it is not loud in the way a city is loud. It does not have sharp edges. The sound is layered. A steady hiss of insects, a soft drip of water from leaf to leaf, the occasional crack of a branch. It is a kind of living static. Your brain tries to pick out patterns, and the jungle keeps offering new ones. You might imagine you are walking on ancient, rich soil, thick and nourishing, because everything grows so aggressively. That is the trick. Tropical soils often look fertile, but the nutrients are mostly in the living plants, not stored safely in the ground. Warmth and moisture speed up decay. Rain can leach minerals downward. The forest survives because it recycles fast, not because it has endless supplies, endless savings tucked away. Remove the trees, and the system unravels quickly. The fertility is not a gift. It is a balance. Somewhere along a low ridge, the air shifts slightly. Not cooler exactly, but less still. The canopy opens just enough for a breath of wind to pass, and you notice the shape of the land in a different way. The Darien is not flat jungle forever. It rises and dips, and those subtle slopes decide where water goes, which decides where mud forms, which decides where you can walk. That is the first lesson here. The map is not made of lines. It is made of flow. You find water, or rather, water finds you. A narrow stream appears, brown and busy, cutting around roots and carrying leaves like small boats. It looks simple, almost harmless. But in the tropics, streams are apprentices. They grow up fast. A little rain upstream, a storm you never see, and the water level changes with unsettling speed. Rivers in places like this are not just features. They are the organizers of the landscape. They are the reason the forest is arranged the way it is. A river decides where the floodplain will be, where the soil will be refreshed, where the trees will tolerate wet feet, and where they will not. It decides where animals travel. It decides where humans can travel to, whether humans like it or not. If you follow the water, the jungle becomes slightly more readable. Not easy, but readable. The river corridor is a kind of natural path, a long opening where the forest steps back just enough to let you see more than 10 feet ahead, and the sound of moving water gives your mind something steady to hold on to, like a low voice in the dark. Of course, the river has its own personality. It acts calm while quietly dragging whole trees downstream. A trunk lodged on the bank is not an accident. It is evidence. It means the river has been higher, stronger, heavier, and it will be again. In the wet season, water does not politely remain inside the channel you imagine for it. It spreads. It borrows the forest floor. It turns familiar ground into moving brown water, full of invisible branches and soft traps. You can see how a river changes its mind. Look at a bend where the current pushes hard against the outer bank. The water eats at it, grain by grain, until the bank slumps with a sound like a sigh. On the inside of the bend, the current slows and drops sediment, sand, silt, and tiny bits of organic debris. The river chews one side and rebuilds the other like a lazy reshuffle. It is not in a hurry. It does not need to be. It has time. This is fluvial erosion, which is a clinical phrase for something very ordinary. Water moves downhill, and it takes pieces of land with it. In a lifetime, you might notice a bank retreat. In a century, the channel shifts. In a few thousand years, the river has redrawn the valley. If you build too close, the river does not get angry. It simply continues being a river, and your building becomes part of the story the water carries away. Riverbanks here can look solid until you step near them. Mud can be more suggestion than ground. A layer of grass holds together the top, like a rug on a rotten floor. Beneath it is saturated soil, heavy with water, waiting for a reason to slide. The reason can be your foot. Congratulations, you have become a minor trigger in the geology of embarrassment. But you also understand why people settle near rivers anyway. Rivers give fish, water, and transportation. In jungle terrain, moving by boat can be the only reasonable way to move at all. For generations, people have used these waterways like streets. They read the current and the season, the way you might read traffic and weather. And still, they spend energy trying to control what cannot be controlled, building near the bank, reinforcing it, watching it fail, rebuilding again. The river is not a single ribbon. It is connected to everything. Rain falls on leaves. Leaves drip onto soil. Soil releases water into tiny channels. Tiny channels meet and become streams. Streams meet and become rivers. And the river itself is the low, moving summary of everything happening uphill. A storm far away becomes higher water here. A landslide upstream becomes a cluster of logs and debris snagged on a bend. The river is a messenger, and it delivers its messages whether you asked for them or not. As you drift along the river, you start noticing the way the land tilts, almost imperceptibly at first. The current has more urgency. Stones appear in the riverbed, where before there was only soft mud. The banks become steeper. The jungle is still thick, but the shape of the terrain begins to rise. And with that rise, the air begins to change. But the river does not stay in the lowlands forever. You can feel the land tilt upward, and the air begin to change. The climb begins quietly. There is no dramatic moment where the forest announces, "Now you are in mountains." It just adjusts. The ground becomes less swamp and more slope. Water runs off faster instead of pooling. The soil feels thinner, and sometimes you can see the bones of the land, rock peeking through, dark and slick with moisture. As you gain elevation, clouds start behaving differently. They snag on ridgelines and refuse to move on. You can watch mist pour through gaps like slow smoke, then settle into the trees. In these places, you do not just walk through weather. You walk through the machinery that makes weather. Mountains feel permanent when you stand at their base. They look like they have always been there and will always be there. But they are not monuments. They are events that take a long time. They are the slow consequences of pressure. Imagine two shopping carts in a parking lot, rolling toward each other at a speed so slow you almost do not notice. Now imagine they keep rolling for tens of millions of years. Replace the carts with tectonic plates. Replace the parking lot with the planet's crust, and the collision does not dent metal. It wrinkles rock. It lifts the land. It folds layers that used to be flat seabed into shapes that look like crumpled cloth. The rocks around you can tell you this story if you know how to look. Layers of sedimentary rock, once laid down in calm water or river plains, can be tilted at strange angles, even turned nearly vertical. Solid stone that you could build a city on has been bent like old fabric. The technical term is folding, caused by compressional forces. The human translation is simpler. The earth can squeeze and the crust can buckle, and nothing you call solid is truly safe from being reshaped. The air cools as you climb, not dramatically at first, just enough that your skin notices. In humid tropics, cooler air feels like relief and like warning at the same time. Clouds thicken. Your view becomes shorter. The world reduces to wet leaves, dark trunks, and the pale gray of fog. And with thinner air, your body becomes a quiet instrument measuring elevation. Breathing is still easy here, but you notice the effort more when the slope steepens. Higher ground means weather changes faster. Sun appears briefly, bright and sharp, then vanishes behind a curtain of mist. Rain arrives without drama, as if the cloud simply decided it was done, holding itself together. This is orographic lift, a tidy phrase for what you feel on your face. Moist air moves toward higher terrain. The land forces it upward. It cools, and water condenses into cloud and rain. Mountains pull weather out of the sky. They make wind climb, and then they wring it out like a wet cloth. On the windward side, forests can be lush, dripping, dense. On the leeward side, where air descends and warms, the same air can become dry. This is how mountains create contrasts, green on one side, brown on the other. If you have ever wondered why there can be a wet region and a dry region close together, you are standing inside the answer, soaked in it. Humans, of course, see mountains and decide to build roads across them. It is a sweet optimism. A road looks decisive when it is new. It cuts through slopes, it bridges gullies, it clings to ridgelines like a thin promise. Then gravity arrives, calm and consistent, and begins the slow undoing. In steep, wet terrain, landslides are not rare disasters. They are a normal way the landscape adjusts. Water seeps into soil, making it heavier, reducing friction, turning a stable slope into something ready to move. A heavy rain can be the final nudge. A whole section of hillside slides down, carrying trees like matchsticks and leaving a raw scar of exposed earth. The ground you walk on is not fixed. It is temporarily arranged. Rocks break down into soil. Soil moves downhill. Rivers carry it away. The mountains are built by uplift and destroyed by erosion at the same time, like a construction project that also has a demolition crew working the night shift. The only difference is that the shifts last thousands of years. As you climb, you might find places where rock is exposed in clean faces, slick with water and streaked with minerals. You run your hand along it and feel the rough grains, and you remember this stone was once part of something else. It may have been sediment on an ocean floor. It may have been volcanic ash. It may have been sand in an ancient river. Mountains are made of recycled worlds. And still, up here, people make lives. They plant crops on slopes. They build homes where flat ground is scarce. They cut terraces into hillsides like stair steps for soil. It works until the rains are heavier than expected, or the hillside is steeper than it looked, or the vegetation that held the ground together has been removed. Then the mountain reminds everyone that it has its own priorities. This is the quiet reality check. The mountain does not punish. It simply behaves like a mountain. Gravity pulls, water lubricates, rock fractures, soil slips. Humans call it tragedy, and the mountain calls it Tuesday. Yet there is something comforting about the way mountains organize the world. They create watersheds, dividing where rivers will flow. They influence climate. They force storms to rise and drop their water. They make ecosystems stack in layers, warm lowland forest below, cooler cloud forest above, and sometimes, if you go high enough, open grassland or bare rock. The landscape becomes a vertical journey through different versions of Earth. And as you stand where the mist thickens and thins, you realize mountains are not just piles of rock. They are climate machines. They are water towers. Snow and rain collect here, feeding streams that become rivers, feeding lowlands far away. People downstream may never see the ridge that shaped their weather, but they live inside its influence. Your path crosses a saddle between higher points, and for a moment, the cloud cover lifts. You see a distant slope falling away, and beyond it, a paler horizon. The air on the far side looks different, less hazy, more bright. It looks drier. You can almost feel it ahead, waiting. And once you have watched mountains pull weather out of the sky, it is easier to understand how a place can become dry, almost by accident. The transition is not immediate, not a doorway you step through, but you begin to notice the signs. Leaves change shape, trees stand farther apart, the ground is less sponge and more grit. When the wind comes, it feels less like warm breath and more like something scraped clean. Somewhere ahead, beyond ridgelines and distance, there is a coastline where the sea is present, but the land stays thirsty. An ocean beside a desert, which sounds like a contradiction until you realize the planet enjoys contradictions. The sea can be generous and still leave the shore parched. Cold ocean water is part of the trick. When currents bring cold water along a coast, the air above cools. Cool air does not hold as much moisture as warm air, so you can get clouds low and thick and fog that rolls in gently. And then forgets to rain. The moisture stays suspended, a ghost of water drifting above ground that rarely receives it. Desert mornings in such places can be soft. Fog slides over sand and stone like a slow blanket, quiet and pale. If you hold out your hand, tiny droplets collect on your skin. It feels like the world is trying to be kind, but the kindness is limited. The sun rises higher, the fog retreats, and the day becomes dry again. Wind becomes the main sculptor. It does not rush. It simply repeats itself, grain by grain. It sands rocks down. It lifts dust and carries it away. It stacks dunes into slow waves that move sometimes only a little each year, but always moving. A dune is not a hill. It is a temporary arrangement of particles, balanced until the wind changes its mind. Life here survives by being careful. Plants are small or tough, saving water the way you save breath when you are climbing. Animals move at night or hide during the day. Everything is adapted to scarcity, and that scarcity is not dramatic. It is just constant, and you can already feel the next link in the chain, because the same wind that shapes sand can also shape something colder, something that looks still but is never truly still. And speaking of wind shaping the world, there is a place where the wind does not just shape sand, it shapes ice. The first thing you notice is how the light changes. Not warmer, not softer, just sharper, like the world has been rinsed clean. The air bites a little when you inhale, even if the sun is out, and the ground under you, which you expect to be rock, is sometimes something else entirely. A pale mass that looks solid, looks harmless, looks like an oversized patch of winter that forgot to leave. You think you are looking at frozen stillness. Wrong. You are standing on motion that has learned patience. A glacier is not a decorative slab of ice. It is a slow river made of compressed snow layered year after year, heavy enough to stop behaving like a brittle thing. Under its own weight, it flows, not dramatically, not like a wave, more like honey in cold weather, taking its time, taking the shape of whatever holds it. If you step onto it, the surface tells one story. It crunches underfoot, granular, wind-sculpted, sometimes dusted with fresh snow that squeaks faintly. But beneath that, the ice is older, denser, pressed into itself until the trapped air bubbles shrink. And where the ice thickens, where it becomes almost glassy, it starts to do something unsettling. It turns blue, not sky blue, not cheerful. A deep, quiet blue, like the color belongs to depth rather than to light. That color happens because dense ice absorbs red wavelengths more easily, leaving the blue to survive the journey back to your eyes. The glacier is not glowing. It is filtering the world. You hear sound differently here. Wind is the main narrator, sliding over ridges and across open ice like it owns the place. And then there are the small noises you did not expect. A faint drip, a soft trickle, the sudden crack of ice shifting somewhere inside itself. It is not loud, but it is personal. It sounds like the glacier is clearing its throat. Congratulations, you have found a landscape that moves and yet never looks like it is moving, which is exactly how it gets away with everything. The glacier creeps downhill because gravity is patient, and because ice, under enough pressure, can deform. The technical phrase is plastic flow. The human translation is simpler. The ice can bend without breaking, as long as you give it time. And glaciers have all the time you do not. Sometimes the ice slides on its bed too. Meltwater forms underneath, not as a cozy pool, but as a lubricating film. The glacier uses it like a slick floor. It does not need wheels. It just needs a little water and a lot of weight. And it is heavy, unimaginably heavy. The kind of weight that presses the land down and changes the rules. When you stand near the edge of a glacier, you are looking at a force that can reshape bedrock the way sandpaper reshapes wood. The glacier carries stones frozen into its base. As it moves, those stones scrape the ground, grinding and polishing, carving grooves called striations. They look like claw marks, except the animal is a whole valley of ice. When glaciers grind rock, they make powder, very fine pale powder, like flour you did not ask for. It washes into streams and turns the water milky. This is rock flour, pulverized mountains, stirred into meltwater until lakes look like melted jade, opaque and strange. Tourists call it magical. The glacier calls it leftovers. And if you follow that milky water downhill, you start to understand the glacier's quiet violence. It does not just sit there, being cold. It excavates. It widens valleys into a U shape, smoothing what rivers would have cut into a sharper V. It pulls boulders along like unwilling luggage. It bulldozes. It drags. It dumps. At the glacier's edges, the debris piles up in ridges, moraines. That word sounds like a person's name, or a small town. It is actually a signature, a line of rock and dirt placed where the ice used to be. When the glacier retreats, it leaves these ridges behind like ribs. Retreat is a polite word, by the way. It makes the glacier sound timid. It is not. It is simply losing more ice in summer than it gains in winter. The front edge melts back, not because the whole glacier is running away, but because it is being erased faster than it can advance. The ice upstream still flows forward. It is just arriving at the end and vanishing. You can stand in front of the ice and watch that vanishing happen. Meltwater runs in thin streams over the surface, finding cracks, disappearing into them without warning. Those cracks are crevasses, open mouths in the ice, sometimes narrow enough to step over, sometimes wide enough to swallow your entire plan for the day. Crevasses form because the glacier is not moving as one solid block. The surface stretches and fractures where the ice flows over steeper ground or around bends. It is like pulling taffy, except the taffy is cold and indifferent. A crevasse can look shallow until you lean closer and see the blue drop, a depth that does not reflect much light, a depth that makes you stop pretending you are in control. The dangerous part is how beautiful it is. The edges can be scalloped and delicate. Snow can bridge the opening with a thin lid, making it look safe. It is not safe. It is a ceiling over nothing. And yet, humans keep coming here, as if the cold is a theme park. They strap metal spikes to their boots. They carry ice axes like props, and they walk across a moving body that has been carving continents since before their language existed. Some of them learn the rules. Many of them just borrow confidence from the weather. The glacier does not care about confidence. It cares about temperature, snowfall, and time. Somewhere upwind, snow falls and stays. It accumulates in layers, compressing into firn, which is snow that has started becoming ice. Firn is like a halfway point, still granular, but heavier, more serious. Over years, it becomes glacier ice. The zone where accumulation exceeds melting is called the accumulation zone. The lower region, where melting wins, is the ablation zone. It sounds technical. It is really just a budget. If more snow comes in than ice goes out, the glacier grows. If more melts than arrives, the glacier shrinks. Simple accounting carried out with blizzards, sunlight, and warm air. And when glaciers shrink, the land they reveal looks new, but not in a friendly way. It is raw and muddy, strewn with stones that were once frozen in place. The soil is thin because soil takes time. Plants arrive slowly. Lichens show up first, crusting onto rock like a patient rumor, then moss, then small flowers that have learned to survive short summers, eventually shrubs, then trees, if the climate allows it. This is ecological succession, the slow process of life moving into fresh ground. It is not heroic. It is methodical. Nature does not rush to fill the space. It just starts and keeps going. The meltwater itself can be messy. Streams braid across gravel plains, splitting and rejoining, changing channels every season. These outwash plains are built from the glacier's debris, washed out and sorted by flowing water. It looks like a wide, shallow river system that cannot commit to a single path. In a way, it is the glacier still speaking, even after the ice has stepped back. And sometimes the retreat leaves behind lakes. Meltwater collects behind moraine dams, or in hollows the glacier scooped into bedrock. The water can be startlingly blue because it is deep, cold, and full of that fine rock powder. But these lakes can also be unstable. A moraine dam is not a concrete wall. It is a pile of loose rock and sediment held together by friction and habit. If it fails, the lake drains in a sudden flood. Humans love building near water. Humans also love pretending that piles of gravel will behave like engineered infrastructure. The glaciers quietly provide the lesson, again and again. And then there is the bigger lesson, the one that takes longer to say out loud. Glaciers are not just scenery. They are storage. They hold fresh water in frozen form, releasing it slowly through seasons. In many mountain regions, glacier melt helps feed rivers during dry months, acting like a savings account that pays out in summer. When the glacier shrinks, the payout changes. At first, more meltwater can mean more flow. Later, as the ice dwindles, the rivers drop in summer, and people downstream discover what it means to depend on something that is disappearing. It is not dramatic in the moment. That is what makes it easy to ignore. A glacier does not vanish like a building collapsing. It thins. It pulls back. It becomes quieter. Its front edge retreats up valley, leaving bare rock like exposed bone. And the land beneath, once crushed under the weight of ice, starts doing something strange. It begins to rise. Isostatic rebound? It sounds like a yoga pose or a questionable mattress advertisement. It is actually the crust of the earth lifting back up after being pressed down by a heavy ice load for thousands of years. When the ice melts, the pressure eases, and the land slowly springs upward. Not quickly, not neatly, but steadily, like a cushion regaining shape. This rebound can change shorelines. It can tilt lakes. It can alter drainage patterns, gently rerouting rivers as if rearranging furniture. And it can even trigger earthquakes because the crust is adjusting, flexing, cracking in places as it relaxes. So yes, the ice leaves and the ground itself responds. The planet does not do stillness. It only does slow motion. In the far north, you can see another kind of ice story. Sea ice forms and melts with seasons, floating on the ocean like a shifting lid. It is not the same as glacier ice, which is land-based and often ancient. Sea ice affects climate by reflecting sunlight, brightening the planet's face. Ice is reflective. Open water is dark, absorbing heat. When ice shrinks, more heat is absorbed, which encourages more melting. A feedback loop, the Earth accidentally stepping on the accelerator. But even if you never think about climate, you can feel the physical truth. A world with more ice sounds like it would be calmer, quieter. It is not. Ice expands and contracts with temperature. It cracks, it groans, it calves. Calving is when a chunk of glacier breaks off into water, usually at a glacier's terminus where it meets the sea or a lake. The ice fractures, a slab separates, and gravity finishes the sentence. The splash can be enormous. Waves roll outward. The sound arrives late, like thunder that waited for you to pay attention. You watch it and realize the glacier is not just melting. It is breaking. It is shedding itself in pieces. And there is an odd intimacy in that. The ice has been holding on to its shape for centuries, sometimes millennia. And then it lets go in a moment. A clean fracture, a collapse, a new iceberg, bright and temporary, drifting away like a thought you almost kept. Humans stand on viewing platforms for this. They sip hot drinks. They point. They take photos. They tell themselves they are safe because there is a railing. The glacier does not care about railings. It is doing what ice does when it meets water and gravity. The deeper you let this sink in, the more you start to notice a pattern that has been following you since the jungle. Water is always involved. Liquid water, carving and flooding. Vapor, hanging in the air and deciding where rain falls. Solid water, crushing and grinding. It changes form, but it keeps doing work. And when the ice finally loosens its grip on a landscape, something else becomes easier to notice. The warmth underneath, not the warm air that melts the surface. The deeper warmth, the heat the planet never really got rid of. Because below the ice, below the rock, below the patient pace, Earth is still running hot. You start to see it in small, almost polite signs. A patch of ground that never freezes. Steam rising in a calm thread. Water emerging from stone already warm, already mineral rich, smelling faintly of eggs and metal. Hot springs, little windows into the fact that the crust is thin compared to everything below it. The surface pretends to be stable. The interior does not. And as you move away from the ice fields, as the air softens and the terrain shifts again, you realize you are not stepping into a new world. You are stepping into the same world, just closer to its furnace. In some places, the furnace speaks in whispers. In others, it speaks in lava. The first time you stand on old lava, you might not recognize it. You expect something smooth, maybe glossy. Instead, it is rough and torn, like the ground was dragged while it cooled. The surface can be jagged enough to shred a boot sole. It looks like a frozen storm. This is basalt, often dark volcanic rock that forms when lava cools quickly. Basalt is common because the mantle is generous with it. It wells up at mid-ocean ridges, spills out at volcanic fields, builds islands one eruption at a time. It is the planet's default building material, and it holds heat differently than soil. Even when the sun drops, the rock can keep a memory of warmth. You feel it in the air, hovering just above the ground. The landscape breathes out heat, like it has been saving it. Volcano country has a particular smell. Not always, not everywhere. But when the vents are active, when gases escape through cracks, there is sulfur, sharp, medicinal, faintly insulting. It reminds you that the air you like is not the only kind of gas the Earth produces. You think volcanoes are mountains with tempers. That is the cartoon version. The tectonic truth is more boring and more unsettling. Volcanoes are plumbing. They are where melt rises, where pressure finds an exit, where the crust fails to keep a lid on the interior. Some volcanoes form at plate boundaries. At subduction zones, one tectonic plate dives beneath another. The descending plate carries water trapped in minerals down into the mantle. Water lowers the melting point of rock. Melt forms. Magma rises. Volcanoes line up like punctuation along a continent's edge. Other volcanoes form at rifts, where the crust is pulling apart. The land thins, pressure drops, and mantle rock melts as it rises. The magma is often runnier here, less explosive, more likely to pour than to blast. It still destroys things. It just does it with a quieter voice. And then there are hot spots, places where mantle plumes rise, like slow blowtorches, punching through moving plates. Islands form in chains as the plate drifts over the hot spot. The volcano you stand on now might be one bead in a long necklace of extinct siblings trailing into the ocean. Volcanoes can sleep for a long time. That is how they win your trust. They build a nice slope. They let plants grow. They let people farm the flanks because volcanic soil can be rich. Fresh ash and lava break down into mineral-heavy dirt. Crops love it. Humans see that and think, finally, the Earth is being supportive. Congratulations, you have built your life on a refillable pressure vessel. The good news is that many volcanoes spend most of their time quiet. The bad news is that quiet does not mean empty. Magma can sit underground, cooling slowly, releasing gases, building pressure, shifting through fractures. The volcano is not dead. It is just thinking. You can sometimes hear hints of it, a low rumble, far away, a subtle shaking underfoot, not enough to knock you down, enough to make your stomach notice. The ground is not a floor, it is a lid. And then there are the gentle reminders, fumaroles, vents that release steam and gases, mud pots, bubbling pools where water, clay, and heat make something that looks like soup nobody should taste. Geysers, rare and dramatic, erupting because underground water is heated beyond boiling under pressure, then flashes to steam and expands violently when it finally escapes. All of this is the surface version of a deeper story. Heat from Earth's formation still lingers. Heat from radioactive decay continues. The mantle convects slowly, moving heat upward. The crust cracks and shifts, and where it cracks just right, the interior makes itself known. People build towns here anyway. They name them after saints. They paint the houses bright colors. They install evacuation routes and then ignore them because the volcano has been quiet for decades and the bakery is good and the view is perfect. You can understand them. The slopes are fertile. The climate can be gentle, and the mountain looks steady in the distance, like a guardian. It is easy to forget that the guardian is also a generator. When a volcano erupts, it can do it in different ways depending on magma composition and gas content. Basaltic magma is usually lower in silica and tends to flow more easily. It can produce lava fountains, rivers of fire, broad shield volcanoes that spread out rather than rising sharply. More silica-rich magma is stickier. It traps gases, pressure builds. When it releases, it can explode, sending ash high into the atmosphere, producing pyroclastic flows, fast, ground-hugging avalanches of hot gas and ash that move with horrifying speed. They are not lava. They are worse. They are clouds that burn. Even if an eruption is not explosive, lava can still be relentless. It moves slowly enough to outrun in many cases, which is comforting, until you realize it also starts fires, cuts roads, buries farmland, and makes decisions for you about where you live now. And volcanoes have a talent for secondary disasters. Ash can collapse roofs. Rain can turn ash into heavy sludge. Melting snow and ice can create lahars, volcanic mud flows that surge down valleys like wet concrete. They follow river channels, which means they go exactly where people like to build. Volcanoes also build new land. They create islands. They refill valleys. They lay down layers that, over time, become rock. The same eruption that destroys a village can leave behind soil that feeds the next generation, which is a very Earth-like kind of compromise. The planet gives with one hand and takes with the other, and never explains itself. You walk across old flows and see textures frozen in place. Ropey lava, called pahoehoe, where the surface cooled while the interior kept moving, wrinkling it like skin. Jagged clinker lava, called air, where the surface broke into sharp blocks as it advanced. The words are short because the lava does not need long explanations. It just needs gravity. And as you look closer, you realize the ground is full of holes. Lava tubes once carried molten rock like pipes. When the lava drained away, tunnels remained. Some collapsed later, leaving skylights and caves. The land is honeycombed, not as stable as it looks. Even far from obvious volcanoes, the crust can remember. Ancient lava flows underlie plains. Old calderas sit beneath forests. A caldera is what happens when a large eruption empties a magma chamber enough that the ground above collapses. It is not the volcano exploding upward. It is the volcano falling inward. A calm lake can fill a caldera. A town can form on its rim. People can live inside the ghost of an eruption so large the landscape itself gave up and sank. And still, most days, nothing happens. That is the strange comfort of geology. The most powerful forces are usually quiet. They build pressure in silence. They shift in millimeters. They wait. So you learn to read the gentle clues: warm ground, strange gases, rock that looks melted, a line of small cones on a plain, each one a past outburst, the smell of sulfur that comes and goes with the wind, like the earth sighing. And while you stand there, letting the heat and the quiet settle into your thoughts, you realize something else. Fire reshapes the surface quickly, but it does not finish the job. It leaves fresh rock, bare and new. And then water arrives. Water always arrives. It arrives as rain that cools lava. It arrives as streams that cut into ash. It arrives as rivers that carry volcanic sediment away. Over time, it carves. It takes the fresh volcanic surface and begins the slow process of making it look old. You follow a river again, but this one feels different than the jungle river. It runs clearer, colder. It moves over rock rather than through mud. It has edges that hold their shape longer, and it has a destination beyond simply escaping the forest. Because in places where uplift and volcanism raise the land, water responds by cutting down. It is the oldest argument on Earth. The land rises, the river incisors, and the result is a wound so large you can stand at its edge and feel dizzy. A canyon does not appear all at once. It is a long, slow insistence. You come to the rim when the light is high enough to make shadows sharp. The air is dry here, often, and the sound travels farther. You hear wind moving through sparse plants. You hear your own movements more clearly, and then you look down, and the world opens. It is deep enough that the bottom looks like a separate day. The shadows down there have a cooler color, like the sun arrives late and leaves early. The walls are layered, banded with different shades, each layer a different chapter of Earth's habits. You think you are seeing a chasm carved by a raging river. Sometimes that is true in floods, in rare moments when water becomes a blunt instrument. But most of the carving is quieter. A river does not need to be fast to win. It needs gravity, sediment, and time, and it has plenty. A river cuts down because it is always trying to reach a lower base level, usually sea level. If the land uplifts, the river steepens and it cuts more aggressively. If the sea level drops, the river also cuts down, chasing that lower endpoint. If the sea level rises, the river may deposit sediment instead. Everything is connected, even if the connections take thousands of years to show up. The canyon walls expose sedimentary layers that once formed in environments that feel impossible now. Some layers were laid down in shallow seas, some in deserts with dunes turned to stone, some in river floodplains. You are looking at places that used to exist here, stacked like papers in a filing cabinet. And the rock itself keeps secrets. Fossils, sometimes ripple marks preserved in stone, mud cracks that formed when a wet surface dried in ancient sun. You can touch those cracks and feel an unsettling intimacy, the shape of a drying puddle from millions of years ago, held in rock like a memory. The canyon is not just a cut, it is a cross-section of time. And time is not smooth. You see unconformities, places where layers are missing, where erosion removed rock before new layers were deposited on top. A gap in the record, a missing chapter. The Earth does not archive perfectly. It edits, it deletes, it overwrites. People stand at canyon rims and feel brave because there is a fence or because the rock looks solid. But cliffs are honest about one thing. They are always falling apart. Up close, the wall is not clean. It is fractured, crumbly, full of loose blocks and talus slopes, piles of fallen rock at the base. Freeze-thaw cycles can wedge cracks open. Water seeps in, freezes, expands, and pries rock apart with slow persistence. In hot deserts, thermal expansion and contraction can also stress rock, especially in the surface layers. Gravity collects the results. So the canyon is being carved from below by water and widened from the sides by collapse. It is a collaboration between a river that cuts and a cliff that cannot hold itself together forever. Humans inevitably try to live near canyons too. They build roads along rims because the view is good and the land feels stable up there. Then a section collapses and takes part of the road with it, and everyone acts surprised, as if gravity is a new invention. Down in the canyon, the river may look calm at times. It may glide reflecting sky. It may whisper over stones. And then, after a storm upstream, it can rise quickly, turning side canyons into funnels. Flash floods race through narrow channels, carrying rocks, branches. A dry wash becomes a violent conveyor belt. The canyon does not need to be wet to be dangerous. It just needs weather somewhere else. The landscape you stand in is shaped not only by what happens here, but by what happens far away. Rainfall in distant highlands becomes floodwater in the canyon. Snowmelt, months later, becomes a steady flow that continues carving even when you think the season is quiet. And when the river carries sediment, it uses it as a tool. Sand and gravel scrape the bed. It is abrasion. It is a saw made of particles. The river is both the hand and the blade. The canyon keeps deepening until something changes the equation. Uplift slows. The river reaches a stable base level. The climate shifts. The sediment load changes. But until then, the river keeps working. You stand there long enough and your mind starts to widen with the view. The canyon is not just depth, it is scale. It makes your life feel thin. Your plans feel temporary, not in a tragic way, in a relieving way. The canyon does not care. It never did. That indifference can be oddly comforting. Because if the earth is indifferent, then your small mistakes are not cosmic failures. They are just small. They fall into the same category as a rock tumble or a sand grain blown off a ledge. Speaking of sand grains, the river does not keep them forever. It carries them onward, out of the canyon into broader valleys. It slows. It drops some sediment. It picks up more. It meanders. Eventually, whether it takes days or centuries, the river reaches the coast, and when it does, the story widens into salt air. The first hint is smell. Even before you see the water, you taste it in the wind, salt, algae, the faint iodine edge of living oceans. The air feels different. Heavier in a new way, damp but cooler and always moving. the horizon opens. After forests and canyons, the openness is almost suspicious. You walk onto a shoreline that looks stable in the way a sleeping animal looks stable. It is still until it moves. Waves arrive in repeating lines, each one a small delivery of energy. They break, they rush up the beach, they retreat, dragging grains back with them. It is gentle, it is relentless. Every wave is a tiny experiment. The ocean tries to rearrange the land again and again, and sometimes the land agrees. Beaches are borrowed places. The sand is not permanent. It comes from rivers, from eroding cliffs, from broken shells, from ground-down rock. It is carried alongshore by currents, pushed by waves arriving at an angle. Longshore drift, a tidy phrase for sand being nudged down the coast like a slow-moving crowd. So a beach can widen over years, then shrink in a single storm. People build houses behind it because it looks like a buffer. Then a winter storm arrives and the buffer migrates away, and the sea claims what was always, technically, within its reach. Cliffs at the coast look sturdy from a distance. Up close, you can see the undercutting. Waves attack the base, especially at high tide, especially during storms. They exploit fractures. They pluck blocks away. Over time, the cliff becomes unstable and collapses. The collapse is not dramatic until it is. It can happen on a quiet day, without warning, because the preparation took decades. Congratulations, you have found the edge of a continent, and the continent is losing the argument. The shoreline is not a line, it is a zone. The tides move in and out twice a day, rearranging wet sand, shifting pebbles, tugging seaweed into new patterns. The planet breathes here. Inhale, water rises. Exhale, it retreats. Tidal range depends on coastline shape, ocean basin geometry, and the gravitational tug of the moon and sun. In some places, the tide barely moves. In others, it surges dramatically, flooding wide flats, then draining away so far you can walk where boats were floating hours before. In estuaries, where rivers meet the sea, the mixing is a whole chemistry lesson. Fresh water floats above saltier water at first because it is less dense. The boundary can be sharp, like a hidden seam. Sediment drops out where the flow slows and meets opposing tides. Mudflats build, salt marshes form. These are rich ecosystems and also very tempting real estate for humans who enjoy building on ground that floods on schedule. Barrier islands form where sand accumulates offshore, shaped by waves and currents. They look like protective ribbons along a coast. They are not permanent. They migrate landward over time, especially with rising sea level and storm overwash. People build on them anyway because the view is nice and the ocean is right there. The ocean does not hate them. It simply does not recognize property lines. Storms are where the coast shows its true speed. Wind piles water up. Low pressure lets sea level rise slightly. Waves grow larger and hit higher on the shore. Dunes can be cut back. Beaches can be stripped. In extreme cases, new inlets open through barrier islands, rearranging maps in a single night. After a storm, the coast looks different, even if you cannot say exactly how. The beach slope changes, sandbars shift, driftwood appears in new places. The ocean has edited the shoreline again. and it will keep editing. If you stand still long enough, you can almost feel how temporary everything is. Not just buildings, but the landforms themselves. A headland erodes into a sea stack. Then, the stack collapses into a stump. Then, the stump disappears under waves. Arches form when waves exploit weaknesses in rock, then collapse when the roof cannot hold. The coast is a gallery of features that are all quietly in the process of becoming something else. Even the calmest looking bay is moving sediment around. Even the most postcard perfect cove is a work site. And yet, people come here to feel peace. They listen to waves and think it means stability. But the ocean is not soothing because it is gentle. It is soothing because it is consistent. It repeats. It does not improvise much. It wears things down with regularity. That consistency is what lets you relax into the scale of it. The coast is where you can feel the planet's rhythm most clearly. The tide schedule, the wave sets, the seasonal storms, the slow creep of sea level through time. Sea level itself is not a fixed mark. It rises and falls over geological time, with ice ages, with warming periods, with changes in ocean basin volume, with tectonic uplift and subsidence. When ice sheets grow, sea level falls because water is locked on land. When ice melts, sea level rises. Simple and complicated, because the land can rise too, rebounding after ice melts, or sinking under sediment load, or flexing from tectonic forces. So the shoreline you walk today is not where it was thousands of years ago. It is not where it will be thousands of years from now. The beach is a temporary agreement between land and sea, renegotiated twice daily by tides, and occasionally rewritten by storms. And as the sky darkens a little, as the wind steadies, your thoughts start doing what they always do near the horizon. They zoom out, because you have been moving through connected systems all night. Jungle moisture becomes river flow. River sediment becomes delta mud. Uplift makes mountains. Mountains make rain. Rain makes rivers. Rivers carve canyons. Canyons deliver sand. Sand becomes beaches. Beaches become offshore bars. And the sea takes what it wants and returns what it does not need. You begin to see the planet less as separate places and more as one continuous machine with different moods. Some landscapes feel extreme only because their rules are obvious. In the jungle, water is too abundant. In the desert, it is scarce. In glacier country, it is locked up and heavy. In volcano country, the ground is warm enough to remind you the planet as an inside. At the canyon rim, time is exposed in layers. At the coast, everything is in motion right in front of you. No patience required. The earth is not cruel, it is simply busy. You are the one who needs straight lines and predictable days. The planet needs none of that. It has cycles instead. Wet seasons, dry seasons, freeze and thaw, eruption and quiet, high tide and low tide. These rhythms are older than any calendar you have used. And survival in every environment you passed through comes down to the same small humility. You learn the local rhythm, or you become a footnote. You respect the river's rise, or you lose your camp. You respect the slope's instability, or you become part of a landslide. You respect the desert's thirst, or you run out of choices. You respect the glacier's hidden cracks, or you vanish into blue silence. You respect the volcano's heat, or you discover what ash does to lungs. You respect the canyon's flash floods, or you learn how fast dry ground can become moving water. You respect the coast's erosion, or your house becomes driftwood. None of this is moral. It is mechanical. That is what makes it strangely comforting. The rules do not change because you are tired or hopeful or brave. They only change when the earth changes them, slowly and then suddenly. So when you stand at the shoreline in that salt wind, you start noticing the smallest betrayals of permanence. A line of damp sand, darker than the rest, shows you where the last high tide reached. A scatter of broken shells marks a wave that arrived with more energy than the others. A fresh notch at the base of a cliff tells you the ocean has been working overtime. You are not walking on land that is finished. You are walking on land that is being edited constantly by water that never sleeps. And the strange part is how quiet the work looks. A wave folds over, lays itself down, and withdraws. It does this again and again until the shore looks like it always has. But it has not. The coast is a conveyor belt for sediment. Sand is picked up, moved, dropped, then picked up again. A beach is less like a place and more like a rumor traveling along the edge. When waves approach the shore at an angle, they push sand diagonally up the beach. Then gravity pulls it straight back down. That repeated zigzag is how sand drifts along a coastline over time. Longshore drift sounds like something you do in a lazy river ride. In reality, it is the ocean quietly relocating entire beaches. One bay gets wider, another one thins, and nobody notices until the stairs to the water hang in midair. You can see the result at river mouths. A river delivers sediment like a tired delivery driver, dumping its load at the first chance. If waves and currents are strong, they smear that sediment along the coast. If the water is calmer, the sediment piles up, building a delta. Deltas look stable on maps. They are not stable, they are negotiations. A river tries to build land outward, and the sea tries to flatten it again. And if you stand on a delta, you are standing on soft ground that is still deciding what it is. Mud and silt settle slowly, compressing under their own weight. This subsidence is not dramatic, it is just the ground sinking in thought. Meanwhile, the river keeps changing its channels. It deposits sediment in its bed, making the channel shallower. Then, during a flood, it jumps course, carving a new path to the sea. This is an avulsion, a calm word for a river abandoning your town. Congratulations! You built on a river's unfinished draft. People have always done it. Deltas are flat, they are fertile, they are close to water. They are also low, flood-prone, and inclined to sink. When sea level rises, deltas feel it first. When storms intensify, deltas absorb the impact. And when upstream dams trap sediment, deltas starve. This is one of the crueler jokes of modern engineering. You build a dam for electricity, for flood control, for water storage. The reservoir fills with sediment because rivers carry sediment. Downstream, the river runs clearer and hungrier. A sediment-starved river erodes its own banks and bed to compensate. The delta receives less new material and begins to shrink. The coast retreats, and people act confused, as if the river broke a contract. You can watch the same logic play out on barrier islands. They sit offshore like thin, sandy shields, taking the first hit from waves. They are built by waves and also destroyed by them. A barrier island migrates over time. Storm waves wash sand over the top, pushing it landward. Sea level changes the baseline, and the island rolls inland like a slow wheel. If you build a house on top of that wheel, it does not stop rolling. It just rolls with your living room attached. Sometimes the coast tries to defend itself with rock, sea walls, riprap, concrete blocks stacked against the ocean's persistence. They can protect a specific spot for a while, like holding your hand over a leak. But the energy has to go somewhere. Waves reflect off hard surfaces, scouring sand away at the base. The beach in front of a seawall often narrows, then disappears. So, you get the classic coastal miracle. A wall built to save the shoreline ends up erasing the shore. Farther along, you find a headland, a rocky point resisting erosion better than its neighbors. The sea bends around it, focusing wave energy on its flanks. Weaknesses in the rock become caves, then arches, then stacks. A sea stack looks heroic from a distance. Up close, it looks like a deadline. Wave action keeps undercutting. Wind and rain widen cracks above. Eventually, the stack collapses, becoming a stump, then becoming nothing visible at all. The shoreline looks simpler afterward, like the ocean cleaned up its own artwork. You think the drama is in the collapse, but most of the work is in the waiting. Rock breaks down chemically too, not just physically. Salt spray seeps into cracks, then dries, leaving salt crystals behind. As the crystals grow, they pry grains apart, a process called salt weathering. It is like the sea leaving tiny wedges, one after another. In colder coasts, freeze-thaw adds another slow weapon. Water gets into a crack, freezes, expands, and forces it wider. It repeats until a slab detaches and gravity finishes the job. So you stand at the coast, listening to waves, and the sound becomes a metronome for decay. Not angry decay, just the normal kind. And the tides keep time underneath it all. They arrive, they leave, they return again. They bring water into places that were dry, then drain them. The tides are the moon doing what it does best, pulling gently and never apologizing. The ocean bulges slightly toward the moon, and also on the far side of Earth. As the planet rotates, different coasts pass through those bulges. That is why the timing shifts day by day. That is why some harbors can be calm at dawn and chaotic by afternoon. And that is why the shoreline is never the same line twice. In some places, tides and coastlines combine into something theatrical. A tidal bore can surge upriver, a moving wall of water pushed by the incoming tide. It looks like a river flowing backward, because for a while, it is. In narrow bays, tides amplify. Water is forced into a tightening space, and the range grows larger. Mudflats appear, then vanish, like the land blinking. You can walk out across a tidal flat on sand that looks firm. It is firm until it is not. Underneath can be soft mud, saturated, ready to swallow a boot. This is why coastal rescues are often slow, awkward tragedies. The ground refuses to hold you, and the tide refuses to wait. And in that soft zone, life thrives anyway. Salt marsh plants grow in brackish water, tolerant of salt and flooding. They trap sediment with stems and roots, building land slowly upward. A marsh is a natural wave buffer. It absorbs energy, it reduces storm surge impacts, it filters water. It is also, unfortunately, very easy to drain and develop. Humans look at a marsh and see wasted space. The planet looks at a marsh and sees infrastructure. When you remove it, storms reach farther inland. Coasts lose their soft defenses, and everything becomes harder edged. More seawalls, more pumping, more repairs. Again and again you find the same theme. The coastline does not punish you. It simply continues to move, and it charges rent in a currency you cannot argue with. Even beaches have seasons. In calmer months, sand builds up, creating a wider beach. In stormier months, waves pull sand offshore, storing it in sandbars. The beach is not gone in winter. It is just relocated underwater. Then calmer waves can push some of it back, rebuilding the summer shape. So when someone says the beach is disappearing, sometimes they are right. Sometimes the beach is just traveling. But now, with warmer oceans and rising sea level, the travel patterns change. Storms can be stronger, or at least wetter. High tides ride on a higher baseline. A storm surge during an already high tide becomes a different kind of event. Water reaches farther, stays longer, and leaves more damage behind. Not because the ocean is emotional, but because physics is consistent. Sea level rise sounds like a single number, a neat global average. What you experience is messier. Some coasts rise relative to the sea, uplifted by tectonics, or rebound. Some coasts sink because sediment compacts or groundwater is pumped out. In places where people extract water, the land subsides. Aquifers are like sponges of sand and gravel, filled with water. When you pump the water out, the grains settle closer together. The surface drops. The sea does not need to rise as much to start invading. Congratulations, you lowered your own city into the flood zone. And you can feel how the coast makes you think differently. Your mind stops clinging to the idea of fixed ground. You start seeing everything as flux, like the edge of the map is breathing. That thought follows you inland too, if you let it, because the coast is only one seam in the planet's shifting skin. The same slow forces that move shorelines also move whole continents. If you could drain the ocean, you would see mountain ranges running down the middle like stitched scars, mid-ocean ridges where new crust forms as plates spread apart, black smokers venting mineral-rich water into the deep, building chimneys of precipitated rock. You will never stand there in person, not without a submersible and a long waiver. But you still live in a world shaped by those unseen ridges. They create ocean basins. They affect currents. They help decide where warm water flows and where cold water rises. And currents are one of the quiet reasons your night is cool or warm. They are conveyor belts for heat. The ocean moves energy around like a slow, heavy bloodstream. Warm currents can soften winters. Cold currents can create coastal deserts. Upwelling zones bring deep, nutrient-rich water to the surface, feeding fisheries. That is why some coasts are crowded with birds and boats. That is why others are strangely empty, despite sitting beside the same ocean. Even the sand beneath your feet carries this history. Some beaches are made of quartz, pale and durable, ground down from ancient granite. Some are volcanic, black grains absorbing sunlight hot enough to sting. Some are made of coral fragments and shells, bright white and soft. Those beaches exist because living reefs grew, then broke, then became sand. A beach of shell sand is a cemetery that looks like a resort brochure. The ocean has a sense of irony. As you keep walking, the coast changes character. A sandy shore becomes rockier. The cliffs become taller. The wave energy more focused. You see lines in the cliff face, layers with different textures. Hard layers form shelves. Softer layers retreat faster. This differential erosion makes ledges and overhangs. The cliff profile is basically a graph of rock strength. The ocean is the pen, and time is the ink. And because the ocean undercuts the base, the upper part loses support. It fractures, it slumps, it falls. Sometimes you get a rotational slump, where a block of land slides downward along a curved surface. The top tilts backward, trees leaning at odd angles, like they are reconsidering their life choices. The toe of the slump bulges at the base, closer to the sea. It is slow motion collapse, a hillside giving up politely. Other times it is faster. A chunk drops without warning because water found a hidden crack. You hear a sharp sound, then a roar, then the rattle of debris. The coast does not announce schedules. It only leaves clues. You can see old collapsed scars, fresh and pale. You can see vegetation growing back on older ones, darker and more settled. This is the coastline keeping a record, if you learn to read it. And if you zoom out far enough, you see something else. Whole coastlines can be drowned river valleys, flooded when sea level rose after ice ages. These create estuaries, long inlets, harbors that later become cities. Places like that feel naturally suited for ports. Deep water, sheltered channels, access to inland rivers. But they are also places where the sea is already halfway inland. A storm surge does not need to conquer much. It just needs to arrive on a windy day. So even your most comfortable coastal city is still living inside a temporary arrangement. The sea is patient. It has all night, and that patience is contagious. Standing there, listening to wave after wave, you start thinking in longer time spans. Your mind drifts from tomorrow to the next century, then further, because you have been following a single set of forces, wearing different masks: water, rock, heat, gravity, and air. You started in jungle humidity, where water was too present to ignore. You followed rivers that rearranged their banks like bored architects. You climbed mountains that made clouds out of moving air. You crossed deserts that stayed dry beside an ocean because cold currents refused to cooperate. You stood on ice that looked still while it flowed. You walked on lava that remembered being liquid. You stared into a canyon cut by a river's long persistence. Now you stand at the coast, where tides rehearse the planet's breathing. And the longer you sit with it, the more you notice something simple. These are not separate stories. They are one story told at different speeds. A storm is fast erosion. A glacier is slow erosion. A river is erosion with a path. A wave is erosion with repetition. A volcano is construction, delivered violently. And underneath all of it is the quiet cycling of materials. Rock becomes sediment. Sediment becomes rock again. Mountains rise, then become sand, then become seabed, then become mountain again. This is the rock cycle, which sounds like something you would see on a school poster. But in reality, it is a planet-sized habit. Igneous rock forms when magma cools and solidifies. Sedimentary rock forms when particles settle, compact, and cement. Metamorphic rock forms when pressure and heat change existing rock without melting it. If that sounds abstract, you can translate it into landscape. Volcanoes give you fresh igneous rock. Rivers grind it into sediment. The ocean lays it down in layers. Burial and pressure turn it into stone. Tectonics lift it, fold it, heat it, and sometimes melt it again. So the beach you walk tonight is not just sand, it is a future rock layer waiting to happen. If sea level rises and falls, if sediment keeps arriving, if the right conditions persist, the sand can be buried. Minerals can cement grains together. The beach becomes sandstone. Then, later, that sandstone might be lifted, exposed, and carved into cliffs. It might become a canyon wall. It might become a mountain ridge. Which means the waves you hear right now are not just ending the land. They are preparing the ingredients for the next version. Congratulations! You are listening to the planet recycle itself. Even the air is part of the transaction. Coastal wind carries salt inland, stressing plants that do not tolerate it. It carries sand too, shaping dunes. Dunes are beaches trying to become landforms. Wind picks up dry sand, bounces it in little hops called saltation, and piles it where obstacles slow it down. A clump of grass becomes a trap, catching grains, growing a mound. Over time, dunes can grow into ridges. They can migrate. They can bury roads, fences, entire structures. People often try to stabilize dunes by planting vegetation. Sometimes it works. For a while, sometimes the wind simply finds a way around. Because wind, like water, is a transport system. It moves material from one place to another, and it does it without needing your permission. If you walk behind the first dune line, the sound of the surf softens. The air becomes slightly warmer, less sharp. You step into a sheltered pocket where the coast feels less aggressive, but you still feel the horizon out there, a flat line that suggests deep time because it refuses to show you an end. And that horizon makes your thoughts do something inevitable. They start reaching for a scale where your own survival story becomes smaller, not meaningless, just less central. That is the odd comfort of geography. At night, when you are tired, the planet has been doing this work long before you arrived. It will do it long after. The Earth is not waiting for you to understand it. It is not waiting for you to approve. It is simply continuing. And the most honest way to see that is to hold all the landscapes together in one mind. Not as a checklist of extreme places, but as a connected system. Moisture evaporates from the ocean. Wind pushes it inland. Mountains force it upward, cooling it into rain or snow. That water runs downhill, carrying sediment. Rivers deliver sediment to the sea. Waves redistribute it along coasts. Some sediment sinks to the deep, becoming future rock. Tectonics eventually lift it again, or feed it back into the mantle. Even your own body is part of that. Briefly, you drink water that was once ocean vapor. You breathe air shaped by plankton and forests. You walk on minerals that were once magma. You are not separate from the system. You are a short-term visitor moving through it. That is why the places you would not survive, like the Darien Gap, are not monsters. They are just regions where the system is loud. The jungle is loud with growth and decay. The glacier is loud with pressure and cold. The volcano is loud with heat. The canyon is loud with time. The coast is loud with repetition. And ordinary places are not different in kind. They are only different in volume. Your comfortable town is still on a moving plate. Your quiet backyard is still under a sky shaped by ocean currents. Your local river is still trying to reach sea level, one grain at a time. The only difference is that you have learned to ignore the slow motion. That ignoring is a survival tactic in its own way. If you felt geologic time every day, you would never get groceries done. You would stand in the parking lot thinking about sediment budgets and the patience of waves. Still, at night, you can let yourself notice. You can let yourself imagine the coastline 1,000 years ago. Maybe the sea was slightly lower. Maybe the beach was wider. Maybe the river mouth was somewhere else entirely. You can imagine 1,000 years from now. The tide line shifted inland. The dunes migrated. A cliff collapsed that has not yet decided to fall. And none of it requires a dramatic apocalypse. Just a steady continuation of physics. Even the idea of the Darien Gap, that roadless seam between continents, fits into this. It is not merely politics and engineering. It is rainfall and rivers and mud and slope stability and disease vectors and dense vegetation. Some landscapes resist being smoothed into infrastructure, not because they are evil, but because the cost of forcing them is constant maintenance. A road through wet tropics is a fight against vegetation that reclaims edges overnight. It is a fight against water that undermines foundations. It is a fight against landslides that erase yesterday's work. A road through mountains is a fight against gravity and freeze-thaw and rockfall. A road through deserts is a fight against sand drift and heat cracking and water scarcity. A road across permafrost is a fight against ground that melts and slumps. Even coastal roads, the scenic ones, are a long argument with erosion. The cliff undercuts, the shoulder collapses, and the maintenance budget becomes a lifestyle. So when you say you would not survive a place, what you often mean is something quieter. You would not survive the maintenance, not just food and water, but the mental cost of constant adaptation, the cost of moving at the speed the landscape allows. In the Darien, progress is measured in patience. On a glacier, progress is measured in caution. In a desert, progress is measured in water. On a volcano, progress is measured in luck and monitoring. In a canyon, progress is measured in weather upstream. On a coast, progress is measured in where the sand decided to be today. That is the real theme. Survival is not heroism. Survival is logistics. And logistics are always geographical. Even your sleeping mind understands this. On some level, it is why you dream of getting lost, of roads that do not connect, of houses that flood. Your brain is rehearsing what it means to live on a restless surface. But you can also let it be comforting, because the restlessness is not personal. The earth does not keep grudges. It keeps cycles. The carbon cycle, the water cycle, the rock cycle, the nutrient cycles in soil. all of them looping, shifting, sometimes speeding up, sometimes slowing down. When you burn fossil carbon, you push the carbon cycle out of its old rhythm. That changes climate, which changes glaciers, which changes coasts. It is all connected, even if it takes decades to feel local. But the planet does not respond with anger. It responds with physics. Warmer air holds more moisture, so rainfall patterns shift. Oceans expand slightly as they warm, raising sea level. Ice melts, adding more water. Storm surge rides higher. Coastal wetlands drown if sediment cannot build them upward fast enough. Barrier islands migrate and buildings resist, and the mismatch becomes expensive. This is not the Earth attacking. This is the Earth continuing to do what it does under new conditions. And you, tonight, are just walking through the results of cause and effect. If you want to feel how deep time behaves, you can listen to a cliff face, not the waves, the cliff. There is often a faint trickle somewhere, water seeping through porous layers. That water carries dissolved minerals, slowly altering the rock. It widens cracks, grain by grain. There might be a small pebble fall, a delicate tapping sound, a stone that waited for the right vibration, then let go. These are the small sounds of change. They are easy to miss, which is why change feels sudden when it finally announces itself. A landslide, a cliff collapse, a flood, an eruption. Sudden is often just slow motion that reached a tipping point, so your mind starts to treat time differently. You stop thinking in straight lines. You start thinking in thresholds. A slope holds until it does not. A river stays in its channel until it jumps. A glacier creeps until it calves. A volcano vents until it erupts. A beach exists until a storm rearranges it. This is not pessimism. It is simply how systems behave, and once you accept that, something in you unclenches, because you do not have to believe in permanence to appreciate beauty. A beach is beautiful, even if it is temporary. A glacier is beautiful, even if it is melting. A jungle is beautiful, even if it is trying to rot everything you own. A volcano is beautiful, even if it is a loaded furnace. Beauty does not require stability. Sometimes it is the opposite. You keep walking, and the night deepens. The ocean surface darkens, reflecting less sky, more void. The white noise of waves becomes steadier, less varied, like the planet settling into a familiar groove. And you realize how often humans try to make the planet behave like a room. Clean edges, stable floors, predictable temperatures, controlled water. We build rectangles because we like certainty. The Earth builds gradients because it does not care what you like. A coastline is a gradient between land and sea. A wetland is a gradient between fresh and salt. A mountain is a gradient between warm and cold. A desert is a gradient between scarce and less scarce. Even the Darien Gap is a gradient between continents, ecosystems, and watersheds. A seam, not a wall. That is why it feels like the edge of the map. Maps like clean boundaries. The Earth prefers messy transitions, and this is where your thoughts can begin to drift wider still, not toward an ending, just toward a broader view. You can picture the whole route you have taken, not as a journey across places, but as a journey across processes. In the jungle, you were inside the water cycle at its loudest. Evaporation, condensation, rainfall, runoff, all happening around you. On the river, you are inside transport, sediment moving, banks shifting, channels migrating. In the mountains, you are inside uplift and orographic weather, air turned into rain by force. In the desert, you were inside rain shadow and cold current logic, water withheld by temperature. On the glacier, you were inside stored time, snowfall compressed into moving ice. On the volcano, you were inside the planet's heat engine, new rock delivered to the surface. In the canyon, you were inside incision and exposure, time revealed in layers. On the coast, you were inside repeated erosion and deposition, the boundary rearranging itself. The Earth is not a collection of postcards. It is a machine that runs on energy gradients. Solar energy drives winds and currents. Gravity drives water downhill and ice downhill, and rockfall downhill. Internal heat drives tectonics and volcanism, all of it interacting. And in that interaction, you find the real reason some places feel impossible, not because they are cursed, but because multiple gradients stack in one location. In the Darien, heat plus moisture plus dense vegetation plus soft ground equals slow misery. In glacier terrain, cold plus crevasses plus changing weather. In volcano terrain, heat plus gas plus unstable slopes equals a landscape that can change fast. On coasts, wave energy plus storms plus rising baseline equals constant motion. Humans can survive almost anywhere with enough preparation. But preparation is expensive, and complacency is cheap. So we gamble. We build near rivers for water, then complain about floods. We farm volcanic slopes for soil, then act shocked by ash. We build at coasts for views, then fight erosion with concrete. The planet keeps taking our bets because it never runs out of time. And you can sit with that thought without panic because it does not demand anything from you tonight. It is just a perspective, a reminder that the ground under you is not a promise. It is a temporary surface on a restless planet. Out at sea, beyond where you can see, waves are born from wind. Wind is born from pressure differences. Pressure differences come from uneven heating. Uneven heating comes from a tilted planet turning under the sun. So even the wave sound beside you is connected to orbital geometry, the kind of fact that sounds ridiculous. Until you remember, everything is connected. The tide keeps working in the dark. Somewhere, a river is cutting a bank. Somewhere, a slope is absorbing water and quietly weighing its options. Somewhere, ice is cracking. Somewhere, magma is rising by millimeters. And somewhere, a grain of sand is being moved, again, without ceremony. You can imagine being that grain. For a moment, lifted by a wave, rolled, dropped, dried by wind, bounced inland, trapped by a tuft of grass. Held there until the next storm decides otherwise. It is not a heroic existence. It is not a tragic one either. It is simply participation. And when you imagine the planet like this, the fear of extreme places becomes less personal. The Darien Gap is not out to get you. It is just a place where the planet's normal habits are concentrated, which means there are blank spots on the map everywhere. If you define blank as uncontrolled, a bog that swallows steps, a mountain pass that closes in snow, a river that changes course overnight. A coastline that retreats one storm at a time. The map is full of places that do not care about your plans. You just usually do not notice them from your couch. The tide continues, quiet and unbothered. The shoreline gleams faintly where wet sand reflects starlight, and the world feels very old in a way that does not threaten you. It just places you, because you are not the first person to stand here and feel small. Sailors, fishers, travelers, people with no idea what tectonic plates were, all felt it anyway. They did not need the vocabulary. They had the horizon and the waves and the steady truth that the sea does not stop. And standing here, you finally notice what the sea is really doing to you. It is stretching your sense of time. The waves make everything repetitive, and repetition makes everything honest. Each set arrives, performs the same simple physics, and leaves. No speeches, no closure. Just the quiet implication that this has happened a few billion times already and will keep happening without your opinion. So you let your mind do what it wants. You let it zoom out. You imagine the jungle again, not as an enemy, but as the humid beginning of the same story. Warm ocean water evaporates, winds push moisture inland, and the sky drops it over green slopes until the ground can barely hold itself together. That water becomes a river. That river becomes a canyon. That canyon becomes sediment. That sediment becomes beach. And the beach becomes whatever the next tide decides it should be. It is all one system, trading matter back and forth like a slow conversation. And because you are human, you keep trying to put endings on things. A coastline feels like an ending, a continental edge, a neat border where the land stops. But the coast is not an ending. It is a transfer station. Sand leaves the continent, sinks offshore and becomes part of the seabed. Shells fall and dissolve, feeding chemistry you will never see. Clay settles in thin layers, so slowly it is almost rude to call it motion. And while the surface looks calm, the plate under the ocean is still moving, still carrying all that sediment away like a conveyor belt that never clocks out. In some distant future, that seabed can be folded, lifted, and turned into land again. The beach you walked on becomes a rock layer inside a mountain. Not metaphorically, literally. A quiet little stripe of sand trapped in stone, waiting to be exposed by erosion in some other era, under some other sky. Congratulations. Your footprints are temporary, but your minerals are committed. That is the comfort. If you want it, the planet does not preserve you, but it preserves process. It keeps recycling the same ingredients. Water, rock, salt, heat, air, over and over, in different arrangements, like the same handful of notes played in different songs. And when you accept that, the idea of survival changes shape. You stop treating landscapes as arenas where you win or lose. You start seeing them as places with rhythms you either match or you do not. In the Darien Gap, the rhythm is wet and slow and relentless. In the mountains, the rhythm is lift and fall, cloud and collapse. In deserts, the rhythm is scarcity and wind. In glaciers, it is accumulation and melt, weight and creep. In volcano country, it is pressure and release. In canyons, it is time disguised as stone. And here at the coast, it is repetition, a patient, salty metronome. Most people do not fail in extreme places because they are weak. They fail because they assume the landscape will negotiate. The landscape rarely does. You learn that the hard way when you treat a river like a fixed line. It is not. It is a moving tool that eats one bank and builds the other. You learn it when you treat a slope like furniture. It is not. It is a temporary pile waiting for enough rain. You learn it when you treat a volcano as a view. It is not. It is plumbing. You learn it when you treat a glacier like a floor. It is not. It is a slow, cracked machine that hides holes with snow. And you learn it at the coast when you treat the beach-like property. It is not. It is a shipment. That is why the phrase "you would not survive the Darien Gap" is only half a joke. You would not survive it in the way you survive an airport. You would not survive it on a schedule. The gap forces you to move at the speed of mud, and mud has never cared about your plans. Even now, with satellites and radios and modern gear, the Darien still behaves like a place that resents shortcuts. The air stays wet, the rivers still rise fast, the ground still turns into suction, the vegetation still closes behind you like you were never there. If you get injured, the simplest distance becomes an expensive problem, not because nobody wants to help, but because geography sets the terms. It is the same lesson the Pan American Highway learned when it stopped politely at the edge of that green seam. Asphalt can be brave, but it is not immortal. The jungle wins by outlasting maintenance. And the truth is, the planet is full of Dariens. They just wear different disguises. A tundra plain can look easy until you realize the ground is thawing into a sponge. A salt flat can look smooth until rain turns it into glue. A beautiful alpine meadow can look gentle until a storm arrives and the temperature falls like a trapdoor. A calm canyon can look safe until a thunderstorm upstream sends a wall of water toward you, like a late apology. These are not dramatic villains. They are the normal rules made obvious. So, standing at the waterline, you let the whole night settle into one long connected picture. You have walked through too much earth to keep believing in stable ground. You have also walked through enough to know the planet is not out to hurt you. It is simply operating. The ocean keeps moving heat around the globe like a slow circulatory system. The wind keeps pushing moisture and dust and salt. The rivers keep trying to flatten mountains into silt. The mountains keep rising anyway because plates keep pushing. The ice keeps storing winters. The volcanoes keep reminding you the interior is still hot. And you keep being a warm, small animal who likes straight lines. That is not an insult. It is just a description. Humans are the species that looks at a shifting coastline and says, "I will build my house right there," and then acts offended when the cliff behaves like a cliff. But there is something quietly sweet about it too. You keep trying. You keep adapting. You keep learning. Slowly, often after the fact, you invent drainage canals and slope nets and weather forecasts. You build stilts. You plant mangroves. You design early warning systems. You fail, and then you rebuild with slightly better information. The planet is indifferent, yes, but your persistence is its own kind of weather. And now, as the night continues to thicken, the beach becomes a simpler place. Less visual, more sound. The surf keeps its steady pace. The wind moves in soft pulses. Somewhere farther down the shore, a small collapse of pebbles whispers as a wave withdraws, dragging stones like it is counting them. you could stay here forever. In a way, not physically. The tide would eventually chase you, the cold would get into your joints, and your practical body would demand a blanket and a roof. But mentally, you can stay in this scale, because deep time is not something you have to solve. It is something you can rest inside. You can picture the earth without you, and it is not depressing. It is calming. Forests grow and fall and become soil. Rivers braid and straighten and braid again. Volcanic islands rise and erode back into the sea. Glaciers advance and retreat, leaving ridges of stone like long scars. Coastlines migrate. Continents drift, slow enough to feel imaginary, until you remember the Himalayas exist as evidence of an old collision that never really ended. Even the Darien Gap, that stubborn green nut, will not be the same forever. Rivers will reroute, hills will slump, the forest will shift with climate. Sea level will nibble at lowlands. In the long run, even the most unwelcoming terrain becomes something else. Not because it becomes kinder, just because nothing stays still. And in a smaller time frame, the one you actually live in, the comfort is simpler. You do not have to conquer any of this tonight. You do not have to survive it. You just have to understand, softly, that Earth has its own pacing, and you are allowed to stop racing it in your head. You have followed water in every form. Humid air in the jungle, brown rivers in floodplain mud, cloud wrung from mountains, fog on coastal deserts, bright ice grinding rock into flour, hot springs breathing steam, lava cooled into dark stone, a river cutting down into layered time, waves erasing and rebuilding the same thin edge of sand. One planet, one set of rules, many moods. And if you keep listening to the surf, you can almost hear the rules being repeated. Gravity pulls, water flows, heat rises, rock breaks, sediment moves. Things pile up, things collapse. Life adapts where it can. Humans build and rebuild, making temporary peace with whatever the landscape is doing this century. The sea does not stop, and neither does the rest of the planet. It just moves slowly enough that you can mistake it for stillness. Out there beyond the dark water, the plate beneath the ocean is still sliding, carrying its cargo of sediment away. Somewhere along a boundary you will never see, rock is melting and magma is gathering itself. Somewhere in a high basin, snow is stacking into next year's ice. Somewhere in the tropics, rain is falling hard enough to make a river rise by morning. And somewhere, in a green place that refuses straight roads, mud is quietly inventing new ways to hold your boot. You let that be the closing thought, not an ending, just a continuation, because the map never really finishes. It only pauses between revisions. And when your mind finally wanders off into sleep, the earth keeps working